All right, let's look at a few more examples with our parabolas. So example 5 is another one where we're kind of working backwards. We're given information and we want to try and figure out the equation of the parabola. So we are told that we have a vertex at the point 4, -2, and we have a focus at the point 6, -2. So I'm going to start by just plotting these points so we can get kind of a visual of what our parabola looks like. So vertex at 4, -2, and then our focus at 6, -2. Okay, so from that we can see that our parabola is opening to the right. Okay, so our parabola opens to the right. Okay, so the equation of a parabola that opens to the right is y minus k quantity squared is equal to 4p times the quantity x minus h. So we need to figure out our h and k, and we need to figure out the p value. So h and k is easy. Remember, h and k are just the vertex. So with a vertex at 4, -2, that is our h and k. And then remember the p-value is just the distance from the vertex to the focus. So those are 2 units apart. So p is equal to 2. So just plugging it in, we'll have y minus 4 quantity squared is equal to 4 times 2. And then here, since it's a -2, oh, I realized I just plugged in the wrong value. So that is a perfect example of what not to do. Right? I was being a little careless here, so be careful. So our vertex is at 4, -2. So the y piece of our vertex is -2. So this piece right here should have been y plus 2 quantity squared. And then the x coordinate of our vertex is 4. So we should have an x minus 4. Okay, so definitely be careful there to make sure you're putting the x with the x and the y with the y. Okay. Okay, so then just simplify this a little bit. So we're going to have y plus 2 quantity squared is equal to 8 times the quantity x minus 4. So that is our answer. Okay. So I always recommend, guys, that when you're trying to find the equation of a parabola from given information, that you make a sketch of it, because I think that sort of helps just organize the information if you have a visual of it, and it'll make the process easier to find the equation. Okay. All right, so example 6 is a little tricky. So this one's different because if you look at our equation, x squared minus 4x is equal to 4y plus 4, it's not in that standard form that we would expect for the equation of a parabola. So the very first thing that we're going to have to do in order to get this in standard form is we're going to have to complete the square. So this goes back to what we did with our circles to complete the square in order to get our equation in standard form. Okay, so I'm going to leave my x terms on the left-hand side, but I want to think about what do I need to add to the x squared minus 4x in order to make this a perfect square. And then we'll have the 4y plus 4 on the right. And of course, we know that we always have to keep our equation balanced. So whatever we add on the left, we have to add on the right as well. Okay, so remember, to complete the square, we take our b term, which in this case is a -4, divide it by 2, which gives us a -2, and then -2 squared is a +4. So if we add a +4 to the left-hand side, we have to add a +4 to the right-hand side. Okay, and it's only the x that we have to worry about completing the square on, because that's the only variable that is squared, right? The y is just a plain y, so there's nothing squared, there's nothing to complete. Okay. All right, so go ahead and simplify this then. So the left-hand side would factor then as x minus 2 quantity squared, and then the right-hand side is going to be 4y plus 8. Okay. Well, the other thing on the right-hand side now, we want to pull out our greatest common factor. So in this case, we could pull out a 4. So we're going to have x minus 2 quantity squared is equal to 4 times the quantity y plus 2. Okay, all right, so now we have that equation in standard form and we're ready to start working with it. So if your equation is expanded out and you don't have the factors for the x minus h and the y minus k, then you have to complete the square first, put it in standard form, and then you have something to work with. Okay, so let's go ahead and think about breaking down our equation into the 4 times p. So we'll have x minus 2 quantity squared. And then we want to think 4 times what would equal 4? Well, 4 times 1 equals 4. Okay, so our p value in this case is equal to 1. Okay. All right, now with an x squared and a positive coefficient on our y, our parabola is going to open up. From the h and k, we'll have our vertex at the point 2, negative 2. Let me go ahead and plot that actually. So 2, negative 2 is our vertex, which means the axis of symmetry is the vertical line at x equals 2. Okay. All right, the focus then is going to be 1 unit up from the vertex. Okay, so if we start at the vertex and go 1 unit up, we will have our focus at the point 2, negative 1. The directrix line then is going to be 1 unit below the vertex. So if we go 1 unit down from the vertex, remember our directrix line is perpendicular to the axis of symmetry. So it is going to be the horizontal line at y equals negative 3. And then lastly, for the latus rectum, okay, the length of the latus rectum is equal to 4p. So in this case, that's 4. And the length of the latus rectum is 4, which means from the focus, we're going to go 2 units left and 2 units right to find the points on the latus rectum. So 2 units left and 2 units right will give us the points at 0, negative 1, and 4, negative 1. And then just connect points. And we have our graph. Okay. All right, let me show you guys one more example. This one we're going to look at an application problem. All right, so in this case, we have a mirror shaped like a paraboloid of revolution. Okay, so paraboloid of revolution basically just means if you take a parabola and then rotate it around 360 degrees, you would form a three-dimensional object, but it's still basically parabolic. Okay, all right. So this is used to concentrate the rays of the sun at its focus. Okay, so we have this mirror shaped like a paraboloid, and then we're concentrating the sun right here, creating a heat source. Okay, all right, so the mirror is 20 feet across, and its opening is 6 feet deep. And we want to know, where will the heat source be concentrated? Okay, so basically, where will the heat source be concentrated? It's asking us, where's the focus? Okay. All right, so I'm going to go ahead and sort of place this within a coordinate system. Now, because this is a physical object, it doesn't have doesn't have a coordinate system to begin with, so we can sort of place it wherever we want to. And the easiest place to draw this would just be to say that the vertex of the parabola is at the origin. And we have the freedom to do that, because we're just sort of arbitrarily creating this coordinate system. So I'm going to put the vertex, for simplicity's sake, right at the origin, right at 0, 0. Okay, and again, we're trying to figure out where our focus is, which means we need to find P. Okay. Okay, now this other piece of information here, it told us that the mirror is 20 feet across and the opening, it's 20 feet across at the opening and it is 6 feet deep. So if you think about this as saying it's 20 feet across, so from the center it would be 10 feet to the right and 10 feet to the left, and the depth of it is 6, so that's basically telling us the y. So your instinct might be to assume that this is talking about the lattice rectum, but it does not specify that this is the lattice rectum, so we just have to assume that it's just an arbitrary point on the parabola. So we can think of this as basically it's giving us two different points on the graph. It's giving us a point at 10, 6, and it's giving us a point at negative 10, 6. Because again, 20 feet across means it's 10 to the right and 10 to the left. Okay. So we said we're placing our vertex at the origin for simplicity, and the way that we have this sketched out, our parabola is opening up. So parabola opens up, which means that we're dealing with the equation x minus h quantity squared is equal to 4p times the quantity y minus k. Okay. All right, so we said again that our vertex is at 0, 0, so we know that that is the h and k, so we can go ahead and plug those in. So if we plug in 0 for both h and k, x minus 0 quantity squared is equal to 4p times the quantity y minus 0, or x squared is equal to 4py. All right, so then remember, we're trying to figure out where the heat source will be concentrated, which means we're trying to figure out where the focus is located. And in order to figure out where the focus is located, we need to find P. Well, luckily, we've been given a tool to do that. We have these points here at negative 10, 6 and positive 10, 6. So basically, if we plug in a point for our x and y, we'll be able to solve for P and figure out the location of that focus. So we are going to plug in the point. I'll just choose positive 10, 6. It doesn't make any difference. You could plug in the negative 10, 6 if you want to solve for P. Okay. All right, so we're going to have 10 squared is equal to 4p times 6. So that would give us 100 is equal to 24p. Divide by 24 on both sides. And if you plug that into a calculator, we would get about 4.17 for p. Okay, so p, remember, tells us the distance from the vertex to the focus. So it's telling us that the focus is 4.17 feet from the base of the mirror. Okay, so the heat will be concentrated .17 feet from the base. Okay. All right, guys, so that is it for parabolas.